Hello everyone! In previous videos, we talked about how to use Gauss-Jordan elimination to solve linear equation system. We will introduce a different angle to look at the linear equation system today, the vector angle. Here is another example which has 4 unknowns in 3 equations, and this is its augmented matrix. We can get the reduced row echelon form of its coefficient matrix by iteratively applying Gauss-Jordan elimination. We can find something interesting if we put the unknowns back into the final augmented matrix. We obtained a fixed solution for x3 and x4. However, x1 and x2 remain unknown. Looking back at the reduced row echelon form of the coefficient matrix, we can find 3 pivots corresponding to x1, x3, and x4, which are called basic variables. x2, however, is not associated with any pivot, so it's called free variable. If we let the free variable x2 to be t, we can represent x1 with t in an equation form. The solution set of the linear system can be written like this, with x1 written as a dependent variable of x2, whose value is t. Furthermore, we can use the vector form to present the solution set as a combination of 2 vectors, with t being a scalar of one vector, while the other vector is a constant. Since t can be any arbitrary real number, the solution set is actually a line in the 4-dimensional space. The eventual augmented matrix after Gauss-Jordan elimination may vary depending on the linear equation system. However, there are certain rules to follow. The first rule is, if there is a pivot in the last column, there would be no solution for the linear system. The reason is, the corresponding equation of the row with the pivot at the end has 0 as the coefficient for all unknowns, which means it should be 0 on the right side of the equation, which is contradict to the given equation. Rule second, if there is a pivot in each column except the last column in the final augmented matrix, the linear system has a unique solution. There is no free variable in this case, and the solution set can be simply written as a constant vector. Rule third, if the last column of the eventual augmented matrix does not have a pivot, while at least one of the other columns does not have a pivot either, then there are infinitely many solutions for the linear equation system. In other words, when there are free variables, the linear system has infinitely many solutions. In this example, x2 and x4 are free variables, which are represented by s and t, respectively, in the vector form of the solution set. Since the solution set has 2 free variables, it represents a plane in a 5-dimensional space. This is the end of this video. There will be more videos to help you discover the secrets of linear algebra. Please subscribe to my channel and stay tuned. Thank you for watching today.